Whether you're sipping your morning coffee or catching up later, we've got your industry insights. I'm Steve.
And I'm Claire. Welcome to Auto Intelligence, produced by AutoAgentic AI.
New episodes drop every Tuesday, Thursday, and Saturday. And today, we're diving deep into something that's fundamentally reshaping how we think about transportation, the data revolution in mobility.
Steve, when we talk about data in automotive, most people think about infotainment systems or maybe GPS navigation, but what we're seeing now goes so far beyond that. We're talking about vehicles that are essentially data centers on wheels, cities that can predict traffic jams before they happen, and manufacturing plants that exist both physically and virtually.
Absolutely. And here's what caught my attention. This isn't just about making cars smarter. We're looking at a complete transformation of how societies move. From Uber essentially reinventing the bus with their new route share service, to cities potentially saving hundreds of billions of dollars through digital planning tools.
Let's start with the foundation of all this, the sheer volume of data we're talking about. Steve, when you get in your car tomorrow morning, that vehicle is going to generate an incredible amount of information.
The numbers are staggering, Claire. Connected vehicles can generate vast amounts of data, but here's where it gets interesting. The figures vary wildly based on what kind of vehicle we're talking about. A basic connected car might generate tens of gigabytes per day, but when you move into highly autonomous vehicles equipped with LiDAR, cameras, and radar systems, some sources indicate figures from 25 gigabytes per hour to over a terabyte per day.
That's the equivalent of 500 HD movies, or 200,000 songs every single day from one vehicle. And this isn't just theoretical. This is happening right now on roads around the world.
What's fascinating is how comprehensive this data collection has become. We're not just talking about location from GPS. Modern telematics systems are capturing vehicle speed, extreme acceleration, and braking from G-force sensors, live energy consumption, vehicle status, including things like tire pressure and battery levels, occupant information like seatbelt usage, and even video from on-vehicle cameras.
And here's the key insight. While data from a single vehicle journey provides limited value, when you aggregate connected car data from millions of vehicles, you create detailed intelligence about traffic patterns, infrastructure utilization, and mobility behaviors that can inform everything from individual route optimization to citywide transportation planning.
Speaking of history, it's worth noting that this connected car journey began earlier than many people realize. The first connected car was actually manufactured in 1996 by General Motors, working with Motorola Automotive when they introduced the OnStar system in Cadillac models.
That's nearly 30 years ago, but the sophistication we're seeing today is on a completely different level. Let's dig into how this data is transforming our cities.
Claire, when we talk about smart cities, we're really talking about urban environments that can think and respond in real time. And the results we're seeing are remarkable.
The traffic management applications alone are game-changing. Studies show that big data-driven systems with real-time adaptive signal control can achieve a 15 to 25% reduction in travel times in high-traffic areas. Imagine cutting your commute by a quarter, just through better data analysis.
But here's where it gets really interesting. Digital twin technology. These are high-resolution, data-rich virtual models that integrate real-time information about buildings, infrastructure, population movements, and transportation networks. Cities can literally test strategies in a virtual environment before implementing physical changes.
And the economic impact is substantial. According to global tech market advisory firm ABI Research, cities could achieve cost savings of up to $280 billion by 2030, through the use of digital twins for more efficient urban planning.
Singapore provides the most ambitious example of this technology in action. Their Virtual Singapore initiative is widely recognized as creating the world's first comprehensive 3D digital twin of an entire country. They used laser scanning aircraft and vehicles equipped with precision laser systems to capture detailed terrain and surface information.
What's remarkable about Singapore's approach is the comprehensiveness. The digital model encompasses above-ground features like buildings, roads, and green spaces, as well as underground infrastructure. This creates a platform for testing urban scenarios and optimizing strategies for sustainable development, efficient resource allocation, and emergency response planning.
The practical applications are already delivering results. Cities can automatically share real-time traffic data with drivers through applications and integration with satellite navigation systems, enabling automatic rerouting to avoid congestion. Parking sensor data can identify the nearest available spaces, eliminating the time and fuel waste associated with searching for parking.
This integrated approach provides a more seamless driving experience while encouraging people to utilize city transportation infrastructure. It's not just about efficiency, it's about making urban mobility more pleasant and accessible.
Now let's talk about a fascinating case study that perfectly illustrates how data analytics can create entirely new transportation models. Claire, you've been following Uber's route share launch.
This is such an interesting development, Steve. Uber announced the launch of route share in May 2025, initially available in 7 US metropolitan areas: New York City, San Francisco, Chicago, Philadelphia, Dallas, Boston, and Baltimore.
What makes route share compelling is how it bridges the gap between private ride-hailing and public transit. The service operates on a fundamentally data-driven model that analyzes commuting patterns to establish fixed routes and schedules with designated pickup and drop-off locations.
The operational model is quite clever. Route share provides consistent and frequent pickup options along direct routes during morning and evening commute hours, 6 to 10 a.m. and 4 to 8 p.m. local time, Monday through Friday. Pickups happen every 20 minutes along busy corridors during weekday commute hours.
Users walk a short distance to predetermined pickup points at scheduled times, where they join up to 2 other passengers on shared trips along optimized routes designed to minimize detours. As Uber's head of product Sachin Kanzal explained, we ask the riders to walk a few blocks to a predetermined point at a predetermined time to participate in a predetermined route, which they will share with a couple of other riders.
Critics have been quick to point out that this essentially replicates many characteristics of public bus service. Social media users have been mocking the service as Uber's invented buses. But the data integration capabilities and dynamic optimization distinguish route share from traditional transit.
Exactly. Unlike fixed public bus routes, route share can theoretically adjust routes, timing, and capacity based on real-time demand data and traffic conditions while maintaining integration with Uber's broader mobility ecosystem.
The pricing model reflects sophisticated data analysis. Uber claims route share fares cost up to 50% less than comparable UberX rides. They're also exploring partnerships with employers to make route share eligible for commuter benefits, enabling customers to use pre-tax dollars, while providing Uber with additional data about corporate commuting patterns.
What's particularly interesting is how this represents a shift toward what experts call mobility as a service, or MaaS. These platforms enable users to plan, book, and pay for a variety of mobility services through a joint digital channel, representing a shift away from personally owned transportation toward shared forms of mobility provided as a service. You're listening to Auto Intelligence, brought to you by AutoAgentic,
the platform transforming automotive retail with intelligent, human-centered AI.
Now back to today's topic. Let's explore how this data revolution is transforming automotive manufacturing itself.
The automotive industry is experiencing fundamental transformation, driven by data analytics and digital technology integration. Digital twins have become essential tools for original equipment manufacturers and suppliers to optimize efficiency, adapt to electrification requirements, and enhance real-time decision-making.
BMW's Munich plant provides a compelling illustration. The facility's digitalization enabled the restructuring necessary to accommodate production of Neue Klasse electric vehicles alongside internal combustion engine and hybrid models. This transformation will see the plant exclusively produce all electric models by the end of 2027.
The digital twin implementation allows BMW to model production changes, optimize workflow, and minimize disruptions during the complex transition to electric vehicle manufacturing. This is crucial because managing multi-powertrain production, electric vehicles, hybrid systems, and traditional internal combustion engines, often within the same facilities, presents enormous complexity.
Horse, a powertrain manufacturer, has implemented an even more comprehensive strategy with 37 distinct digital twin projects underway at its Valladolid plant in Spain, claiming full digitalization of operations.
This level of adoption demonstrates how automotive suppliers are leveraging digital twin technology. not just for individual process optimization, but for comprehensive operational transformation. The scope includes production line optimization, quality control enhancement, predictive maintenance scheduling, and supply chain coordination.
Leonardo Fonteles, co-founder and CTO of Cintu, emphasizes the strategic importance. There's a strong need to digitalize processes before implementing physical changes to avoid wasted time, materials, and resources. This philosophy reflects a broader industry shift toward data-driven decision-making that minimizes costly physical iterations.
The pandemic and persistent supply chain disruptions have accelerated this adoption. Digital twins have emerged as vital tools for operational resilience and agility, enabling manufacturers to model disruptions, reroute resources, and optimize material flows through virtual simulation before implementing physical changes.
Now, let's address the environmental and societal implications of this data-driven transformation, because the stakes here are enormous.
Transportation represents a significant contributor to global greenhouse gas emissions. In 2019, the transport sector was responsible for approximately 25% of the European Union's total CO2 emissions, with road transportation accounting for 71.7% of these transport-related emissions.
In Canada, we're seeing similar patterns. The transportation sector saw a notable rebound in emissions between 2020 and 2021, with reports indicating an increase in the range of 5 to 6% in transportation greenhouse gas emissions during this period.
This was significantly driven by the freight transportation sector, which experienced a 60% increase in activity in 2021 compared to 2020, as pandemic-related restrictions eased and economic activity increased.
These statistics underscore why data-driven optimization systems are so critical. When smart city traffic management systems achieve 15 to 25% reductions in travel times, that directly translates to reduced fuel consumption and lower emissions.
Connected car data enables optimization of energy consumption patterns, which is particularly important for electric vehicle fleet management. Charging routines can be optimized based on grid demand and renewable energy availability.
The societal benefits extend beyond environmental impact to encompass fundamental changes in urban livability and accessibility. Smart mobility solutions that provide choice over transportation modes and control over journey planning contribute to more livable, sustainable cities that can attract and retain businesses, residents, and visitors.
However, this transformation also raises important questions about data privacy, digital equity, and the potential displacement of public transit systems. The success of data-driven mobility solutions requires addressing concerns about surveillance and ensuring that data collection serves public rather than exclusively private interests.
Let's look ahead to what's coming next in this data revolution. The convergence of data analytics with emerging technologies promises to further transform mobility ecosystems.
5G network infrastructure is a game changer here. It enables faster transmission of larger data volumes in real time, providing city authorities with enhanced control over dynamic mobility landscapes. This enhanced connectivity supports more detailed data collection and faster decision-making, such as immediate road closure implementation following accidents or real-time traffic signal optimization.
Internet of Things, sensor deployment continues expanding exponentially as costs decrease. Modern sensors can be easily integrated into existing transportation infrastructure, including traffic lights and vehicles, as well as embedded within urban environments to monitor all aspects of mobility.
Artificial intelligence development relies fundamentally on comprehensive data access. Greater data availability enables more informed AI decision-making and improved prediction accuracy. AI applications in mobility include modeling the impact of infrastructure changes on journey times, traffic congestion, and emissions within digital twin environments.
Autonomous vehicle technology represents perhaps the most transformative application of data-driven mobility systems. Cities worldwide are testing autonomous vehicles for both passenger and freight transportation, with the potential to fundamentally reshape urban mobility and reduce congestion.
The Cassie shuttle trial in North Carolina exemplifies the importance of data sharing for autonomous transport development. This partnership between the North Carolina Department of Transportation and the town of Cary introduced an all-electric self-driving shuttle, with complete project data available through Carrie's open data portal.
This transparency provides comprehensive visibility into performance metrics, including ridership numbers, service disruption causes, and usage pattern analysis, helping build public confidence while driving technology improvements in real-world settings.
As we wrap up today's deep dive, it's clear that the data revolution in mobility represents a fundamental transformation that extends far beyond technological innovation to encompass economic, environmental, and social change.
From Uber's route share demonstrating how data analytics can create new transportation models, to comprehensive smart city digital twins enabling billion-dollar savings through optimized planning, we're witnessing the emergence of intelligence-driven systems that promise to reshape how societies move.
The automotive industry's embrace of digital twin technology and data monetization strategies indicates a fundamental shift towards service-based business models and continuous optimization, rather than traditional product-centric approaches.
The environmental implications prove particularly significant. Smart traffic management systems achieving 15 to 25% reductions in travel times translate directly to emissions reductions, while connected vehicle data enables optimization crucial for electric vehicle adoption.
Looking forward, the integration of 5G networks, expanded IoT sensor deployment, artificial intelligence advancement, and autonomous vehicle technology will further accelerate mobility transformation.
Cities that successfully implement comprehensive data sharing platforms and foster collaboration among all mobility stakeholders will be best positioned to capture the economic, environmental, and social benefits of this revolution.
The data revolution in mobility ultimately represents an opportunity to create transportation systems that are more efficient, sustainable, and equitable than ever before possible. Success requires continued investment in data infrastructure, comprehensive stakeholder collaboration, and governance approaches that balance innovation with public interest protection.
This has been Auto Intelligence. I'm Steve.
And I'm Claire. Thanks for joining us for this exploration of how data is reshaping mobility.
This episode was produced by the team at AutoAgentic. AutoAgentic is a pioneering AI-driven platform transforming the automotive retail industry. Founded in 2024, the company delivers intelligent, adaptive solutions designed to help dealerships streamline operations, optimize sales performance, and elevate the customer experience.
With a strong commitment to ethical AI, seamless integration, and real-time insights, AutoAgentic empowers dealership teams, not replaces them. Our platform features over 90 modular agents, covering lead nurturing, inventory optimization, service scheduling, and more, helping dealerships thrive in a fast-evolving market.
What truly sets us apart is our human-centered, consultative approach. We're LLM agnostic, deeply trained on the nuances of the automotive industry, and we partner closely with OEMs and dealer groups to ensure AI implementation is practical, effective, and aligned with real-world goals.
Because true agentic AI isn't just about automation. It's about strategic thinking, collaborative planning, and operational integration. That's why we're known as the most human AI company in automotive retail. We don't just deliver tech, we deliver trusted guidance.
Learn more at autoagentic.ai.